Welcome to this explainer. Today, we're doing a real over-the-shoulder debugging session to demystify the totally opaque world of mobile app network traffic. If you've ever felt like the app you're supporting is just completely hiding its secrets, well, you're in the right place. We have absolutely all been there. You're staring at a generic mobile error screen that just says, "Oops, something went wrong." It is incredibly frustrating, right? But today, we're moving from blind guessing to surgical precision using Charles Proxy. We're going to trade that totally useless interface for a precise JSON payload that highlights the exact issue, like a 400 invalid redirect URI error. Here's our roadmap for today. First, we'll look at the mobile black box, then routing traffic through Charles. After that, we'll decrypt SSL traffic, play around with breakpoints and rewrite rules, and finally, debug a real-world failed login. Section 1. The mobile black box and why mobile traffic debugging actually matters. So to break open that box, we're using Charles Proxy. You can think of Charles as your friendly, man-in-the-middle web debugging proxy. It's essentially a local intermediary that sits perfectly between your mobile device and your remote servers. It actively intercepts, logs, and even manipulates HTTP and HTTPS traffic, so you finally see exactly what's going on under the hood. Section 2. Routing traffic through Charles to bridge the device and the proxy. Setting this whole thing up is honestly a breeze. Step 1, you just connect your mobile device and your macOS machine to the exact same Wi-Fi network. 2, grab your local IP address right from the Charles help menu. 3, jump into your mobile Wi-Fi settings and set the HTTP proxy to manual. And step 4, just punch in that IP address along with port 8888. Doing this ensures literally all mobile traffic is forced right through Charles. Once you hit allow on your Mac, boom. Traffic immediately starts hitting your session log. But there's a catch. You'll probably notice a bunch of unknown statuses. Because the HTTPS traffic is encrypted, we've technically intercepted it, sure, but we can't actually read the payload yet. Which brings us to Section 3, decrypting traffic with SSL and overcoming that encryption roadblock. Look, in a world where encrypted traffic makes up the vast majority of mobile data, the ability to decrypt and manipulate SSL communications isn't just a nice-to-have, it is absolutely Charles's most critical utility. We need Charles to act as a trusted certificate authority so it can decrypt the payload, let us inspect it, and then re-encrypt it on the fly. And here's the exact path to make that happen. First, enable SSL proxying in Charles for your target domains, and *:443 acts as a great wildcard here. Second, grab your mobile device and browse to chls.pro/SSL to download the profile. Third, install that root certificate. And step 4, please do not skip this. You must explicitly escalate trust for that certificate in your device's security settings. If you miss this step, your proxying will fail entirely. All right, Section 4, breakpoints and rewrite rules and manipulating live requests. This right here is where you gain incredible, godlike control. You can literally intercept requests before they even reach the server. You can edit headers and payloads mid-flight. Want to know how your app handles a 500 internal server error? Just mock it instantly using a rewrite rule. You can simulate awful network conditions or force API failures. And the best part, you never have to beg a developer to break a staging server for you. Moving to Section 5, debugging a failed login in a real sandbox scenario. Okay, here's our real-world challenge. We've got an SSO failure. The mobile banking app redirects to auth 0, but then the login just hangs indefinitely. The user is totally stuck. Now, without Charles, an identity failure like this is just a giant black box, leaving support engineers entirely blind. But we are definitely not blind today. Because we included our authentication hosts in the SSL settings earlier, Charles goes right to work. It cleanly intercepts the unencrypted request to the IMS host and immediately highlights a 400 bad request status right on the authorized path. And boom, there is our smoking gun. By inspecting that initial authorization request in plain text, we can compare the expected redirect URI against what was actually sent mid-flight. And there it is, a completely mismatched HTTP versus HTTPS scheme. Just a single, subtle typo, a missing letter S, was causing the entire app to crash. 15. That represents the hours of incredibly frustrating debugging time you can save each and every week by applying the step-by-step proxy methodology. We literally just went from a totally generic, unhelpful error screen to finding a single missing letter in a network request, all in a matter of minutes. So, wrapping up this explainer, you now have the power to illuminate the mobile black box. What hidden network failures will you confidently uncover and fix tomorrow? I really hope you leave this session feeling totally empowered to take complete control of your mobile troubleshooting. See you next time.